This is the second of the recordings having to do with the analysis of the sandwiches data. Let's just take a quick look at the results we've produced so far then, because there is something interesting to learn about the fresh versus frozen sandwich comparison. You can tell by looking at the histograms that basically the frozen sandwiches have lower total fat and they have lower calories. There weren't that many frozen sandwiches, just 15 it turns out, but certainly the pattern seems to suggest that they're a little bit healthier in terms of fat and calories than the fresh sandwiches. And you can see that in a little bit more detail from the tabular results. The mean total fat for frozen sandwiches was 8.5 grams, whereas the mean for fresh sandwiches was 19.9. The average calories for the frozen sandwiches 264.7. The average for fresh sandwiches 443.2. And so certainly looks like those frozen sandwiches were a little bit healthier. It'd be interesting to look at the particular types of sandwiches that were frozen, because there was another variable in the data set called category. But for now, that's the impression that we're left with. Okay, we're not done, because there was a third goal, which was to describe the relationship between total fat and calories. And so how do we do that? Well, total fat is a continuous variable, and so is calories. And when you're asked to describe the relationship between two continuous variables, the first thing to do is to plot one versus the other in a scatter plot. So let's get one from JMP. I'm going to start my JMP session back up here. To get a scatter plot, you simply go to the Analyze option on the menu, and instead of clicking Distribution, what you do is you click on Fit Y by X. Fit Y by X, that just means, look at the relationship between a Y variable and an X variable. So I'll click on that, and then you get to pick the variables. Let's pick T-fat as the Y variable and calories as the X variable. It really doesn't matter which one you pick as which in this particular case. And then I'll click on OK, ignoring all the other options that might be used right now, and you get a scatter plot. And I've got this scatter plot with a line of best fit also drawn in. You can ask for that by clicking on the red triangle, that's called a hotspot, and asking JMP to fit a line, so fit line. And there's the best fitting straight line. And then there's a bunch of statistics which we will, by the end of the semester, we'll know how to interpret most of these statistics. Perhaps not all of them, but most of them. Also, think about this. Once you've got the scatter plot and you see that this best fitting straight line really does seem to fit the scatter plot very well, so we could say there's a nice linear association between total fat and calories. It's always good to supplement this with a correlation calculation, a correlation coefficient. That's a number between -1 and +1, the magnitude of which tells you how strong the linear association is, and the sign of which tells you whether it's a negative or a positive linear association. Now, how do we get that correlation? I'm going to give away a little secret, but the explanation behind the secret is not going to be revealed until the very end of the semester. Sorry, you'll just have to stay tuned. If you take this number from the output that is showing in JMP right now, is 0.9587, and take the square root of it. So take the square root of r squared, and you get the correlation coefficient between the two variables. I believe it's about 0.97. Alright, so there you go. Let me come back to the output, and what I've done is I've cut and pasted that same graph in as figure 3. Here it is, and I've superimposed a little text box which shows the correlation is 0.97. That's figure 3, and if you look back at the sentences I was putting together, I've noted that there was a strong positive linear association between total fat and calories. Correlation equals 0.97, and I refer to figure 3. I noticed I went ahead and also stratified that plot by fresh and frozen sandwiches, and it still looked like there was a strong linear association between total fat and calories, even when you break the plot down by fresh and frozen sandwiches. That's the last thing I'll show you how to do here in JMP. Now I need to get out of this particular output window, so I'll close it by clicking on the X in the top right hand corner, and then that's back to the data table. And now I need to actually go to Graph Builder. So Graph on the menu option, and then Graph Builder, select that from the list. And once again, what I want to do is look at the relationship between total fat, so I'll highlight that and drag it over to the Y column. And between that and calories, so I'll highlight calories and I'll drag that over to the X axis. Now JUMP shows me the scatter plot that I've already seen. It tries to find a line of best fit, but it's smooth. It's not a straight line. I don't want to see that. We're going to be looking at linear associations, and I don't want to see, this is called a smoothed fit. So what I'm doing is right-clicking on the graph and then clicking on points, change to, no, that's not right. I'm clicking on points, remove. Okay, I messed up twice. Let's see if I can get it right the third time. I right-clicked in the graph. I want to click on smoother and remove. Remove the smoother. That's that blue line. It's a smooth fit through the data. Okay, blue line's gone. Now what do I want to do? I want to see this scatter plot broken down by sandwich type, frozen versus fresh. So let me click on frozen in the select columns. Let me drag that over to the top of the grid and release my mouse button. And there you go. You can see that when you look at fresh sandwiches, there's still a straight line relationship. And when you look at frozen sandwiches, even though there are far fewer of them, there's still a pretty obvious linear association, positive linear association there. Those straight line, that straight line appearance in both sections of this graph is so obvious that it's still going to be a very strong correlation between the two. So I went back to my Word document and I added in that last little graphic as figure 4, relationship between total fat and calories by sandwich type. And then I also mentioned that in the sentences that I was putting together. This association also held for fresh and frozen sandwiches, figure 4. Right, I would like you to take a close look at the sentences I put together, at the table that I've included, at the figures that I've included, and just get a feel for what the report looks like, what I've decided to include, what I decide not to include, how I reported the results, and how I formatted the results too in terms of the table at least. This is the type of report that I'm going to expect from you when you're doing homework problems and I say, oh, do an analysis and provide a little report for me. This is a statistical report. This is a result that you're presenting as, one statistician to another. This is not necessarily the same kind of report that you would take in this form and send off to a journal for publication, a nutrition journal in this case, I guess. We've probably got a little too much detail in this report for the typical scientific journal article. But that's okay. We're not publishing this in a journal right now. You're getting reports ready to present to me and other statistician, and I'd like to see as much detail as has been shown here. I'll have more formal and detailed guidelines on how to produce reports later on, but this was a pretty good start. The last thing I want to leave you with is this piece of information. I know that the JUMP portion of this went by very quickly. We really haven't taught you how to use JUMP. I've just quickly opened it up and clicked on a few menu options. Well, if you don't like JUMP, you don't ever have to use JUMP. That's fine. You learn how to do all of this in SAS, and we'll certainly be learning about that in labs. But statisticians use a variety of tools. Sometimes I like to use tools like JUMP because they're quick and easy. They get me a simple exploratory data analysis very quickly without having to write any programming statements. Sometimes that's a good starting point for your analysis, at least. Maybe when the analysis gets deeper and uglier, you want to go to a slightly more powerful tool such as SAS. Alright, don't stress about not knowing all the details about any software package right now. By the end of the semester, you'll be good at any software package that you want to become good at. Alright? Thank you.